Welcome to the world of Android development, where every app update feels like walking a tightrope. Imagine releasing a major update, packed with new features, only to see your crash reports skyrocket and your app ratings drop overnight. The culprit: users still running older versions of your app on a dizzying variety of devices and Android flavors. This is the Android Upgrade Challenge. How do you keep your app fresh and innovative while ensuring it works seamlessly for everyone everywhere? In this video, we'll explore the best practices for mastering app updates and backward compatibility, so you can evolve your product without leaving users behind. Backward compatibility isn't just a technical detail, it's a lifeline for your app's reputation and user retention. With Android's fragmented ecosystem, users may be running dozens of app versions across thousands of device types. Unlike web development, where you control the code in the browser, Android developers must plan for a chaotic reality. If you retire a legacy API endpoint, you risk breaking features for users who haven't updated. That's why a robust compatibility strategy is not optional. It's essential for keeping your app stable and your users happy. Android's ecosystem is famously fragmented. Developers must account for thousands of unique device types, custom OEM skins, and different Android OS versions. This fragmentation means that a single update can have unpredictable effects across your user base. Planning for this diversity is crucial. You need to anticipate how your app will behave not just on the latest flagship device, but also on older phones and tablets that users may still rely on every day. Building a production-grade app update strategy means thinking beyond the latest release. It's about ensuring that every version of your app, old and new, can coexist without causing crashes or user frustration. This requires a mix of technical planning, user empathy, and a deep understanding of how Android works under the hood. In the next scenes, we'll break down the core components of a winning backward compatibility strategy. One of the most effective tools in your compatibility toolkit is API version negotiation. This means your app checks which version of an API is available on the device and adapts its behavior accordingly. By negotiating API versions, you can gracefully degrade features for older devices while still offering the latest and greatest to users on new hardware. This approach minimizes the risk of crashes and ensures a smooth experience for everyone. Capability-based coding is another essential practice. Instead of assuming that every device supports every feature, your app checks for specific capabilities before enabling them. For example, you might check if a device supports biometric authentication before showing a fingerprint login option. This approach prevents errors and creates a more resilient app that adapts to each user's device. Feature flags allow you to turn features on or off without releasing a new version of your app. This is especially useful for rolling out new functionality gradually or disabling a feature if it causes problems. By controlling features remotely, you can respond quickly to issues and keep your app stable, even as you experiment with new ideas. Microkill switches are a powerful tool for managing risk. These are small, targeted switches that let you disable specific features or code paths if something goes wrong. For example, if a new payment method starts causing crashes, you can turn it off for affected users without pulling the entire app. This keeps your app running smoothly, even when unexpected issues arise. A tiered update strategy means rolling out updates in stages, rather than all at once. You might start with a small group of users, monitor for issues, and then gradually expand the rollout. This approach helps you catch problems early and minimize the impact of any bugs. It's a proven way to keep your app stable during major upgrades. Backward compatibility means planning for the continuous coexistence of multiple app versions. Your users won't all update at the same time, and some may never update at all. By designing your app to support old and new versions side by side, you can avoid breaking changes and keep everyone happy. This requires careful planning and a commitment to long-term support. Nothing hurts your app's reputation faster than a wave of crashes after an update. By using the strategies we've discussed, API negotiation, capability checks, feature flags, and microkill switches, you can prevent most catastrophic failures. Always test your updates thoroughly and be ready to respond quickly if something goes wrong. User churn: when users abandon your app, often spikes after buggy updates. Backward compatibility is your best defense. By ensuring your app works for everyone, you reduce frustration and keep your user base loyal. Remember, it's much easier to keep existing users than to win new ones. Retiring a legacy API endpoint can have unintended consequences. If even a small percentage of your users are still on older app versions, removing an endpoint can break critical features. Always monitor usage before deprecating APIs and provide fallback options whenever possible. Crash metrics are your early warning system. By tracking crashes across different app versions and devices, you can spot compatibility issues before they become widespread. Set up alerts for unusual spikes and investigate the root cause quickly to maintain your app's stability. Custom OEM skins add another layer of complexity. Manufacturers often modify Android in ways that can affect your app's behavior. Always test your app on a variety of devices and Android flavors to catch compatibility issues that might not appear on stock Android. Supporting multiple app versions is a fact of life for Android developers. Use analytics to track which versions are still in use and prioritize support for the most popular ones. Communicate clearly with users about the benefits of updating, but don't force them to upgrade unless absolutely necessary. Clean architecture helps you build apps that are easier to update and maintain. By separating concerns and keeping your code modular, you can add new features or fix bugs without breaking existing functionality. This approach is especially valuable in a fragmented ecosystem like Android. Jetpack Compose is Android's modern UI toolkit designed for flexibility and backward compatibility. By using Compose, you can create responsive interfaces that adapt to different devices and OS versions. It also simplifies your codebase, making it easier to manage updates and compatibility. Kotlin is the preferred language for modern Android development. Its concise syntax and powerful features make it easier to write safe, compatible code. Features like null safety and extension functions help you avoid common pitfalls and build more robust apps. Coroutines make it easier to write scalable, responsive apps. By handling background tasks efficiently, you can keep your app smooth and responsive, even on older devices. Coroutines also help you manage compatibility by simplifying asynchronous code. Thorough testing is the foundation of backward compatibility. Use device farms, emulators, and real hardware to test your app across a wide range of devices and Android versions. Automated tests can catch many issues, but manual testing is still essential for catching edge cases. Continuous integration, CI, helps you catch compatibility issues early. By running automated tests on every code change, you can spot problems before they reach your users. CI also makes it easier to support multiple app versions and Android releases. User feedback is invaluable for identifying compatibility issues. Encourage users to report bugs and provide feedback, especially after updates. Analyze this feedback to spot patterns and prioritize fixes that will have the biggest impact on your user base. Good documentation helps your team maintain backward compatibility. Document your API changes, feature flags, and update strategies clearly. This ensures that everyone on your team understands how to keep the app stable across versions. Analytics provide deep insights into how users interact with your app. Track which features are most popular, which devices are most common, and where crashes occur. Use this data to guide your compatibility efforts and prioritize improvements. Rolling out new features gradually helps you manage risk. Start with a small group of users, monitor for issues, and expand the rollout as confidence grows. This approach minimizes the impact of bugs and ensures a smoother experience for everyone. Fallback mechanisms are your safety net. If a new feature fails, your app should gracefully revert to a stable state. This might mean disabling a feature or switching to a simpler implementation. Fallbacks keep your app usable, even when things go wrong. Clear communication with your users builds trust. Let them know when updates are coming, what's changing, and how to report issues. Transparency helps users feel confident in your app, even during major upgrades. Android's permission system changes over time. Always check for required permissions at runtime and handle cases where users deny access. This ensures your app remains functional and secure, regardless of the Android version. Security is a top priority for any app. Regularly update your app to address security vulnerabilities and support older versions as long as possible. Communicate the importance of security updates to your users to encourage timely adoption. Optimizing performance is key to backward compatibility. Test your app on older devices to ensure it runs smoothly. Optimize resource usage, minimize background tasks, and keep your app responsive for all users. Android regularly deprecates old APIs. Monitor the Android release notes and update your code to use supported APIs. Provide fallback solutions for users on older versions to maintain compatibility. Automated regression tests help you catch bugs introduced by new changes. Run these tests on every code update to ensure that existing features continue to work as expected. This is especially important when supporting multiple app versions. Comprehensive error logging and reporting systems help you diagnose compatibility issues quickly. Collect detailed logs from all app versions and analyze them to identify patterns and root causes. This enables faster fixes and more stable updates. Some users run custom ROMs or modified versions of Android. While it's impossible to support every variation, aim for broad compatibility by following Android best practices and avoiding device-specific hacks. Keep your third-party libraries up to date to avoid compatibility issues. Outdated libraries can introduce bugs and security risks. Test your app thoroughly after each library update to ensure nothing breaks. Regularly update your Gradle and build tools to stay compatible with the latest Android releases. This ensures your app builds smoothly and takes advantage of new features and optimizations. Follow App Store guidelines to avoid rejection and ensure your app reaches the widest audience. Stay informed about policy changes and update your app as needed to remain compliant. Support for multiple languages and regions is essential for global apps. Test your app with different locales and character sets to ensure compatibility. Internationalization expands your user base and improves accessibility. Accessibility is a key part of backward compatibility. Ensure your app works well with screen readers, high-contrast modes, and other accessibility features. This makes your app usable for everyone, regardless of device or ability. Efficient battery and resource management keeps your app running smoothly on all devices. Avoid unnecessary background tasks, optimize network usage, and respect device limitations to maintain compatibility and user satisfaction. Your app's backend services must also support multiple app versions. Use version APIs and maintain backward compatibility on the server side. This ensures that all users, regardless of app version, can access your services reliably. Platforms like Stackademic aim to democratize coding education, making best practices accessible to all developers. By sharing knowledge and resources, the community helps everyone build better, more compatible apps. The Android ecosystem evolves rapidly. Stay up to date with the latest best practices, tools, and frameworks. Continuous learning is the key to maintaining compatibility and delivering great user experiences. Mastering the Android upgrade tightrope requires a blend of technical skill, strategic planning, and user empathy. By following best practices for backward compatibility, you can deliver innovative updates without sacrificing stability. Remember to plan for coexistence, test thoroughly, and keep learning. With the right approach, you'll keep your users happy and your app thriving, no matter how the Android landscape evolves.